Hello students, in continuation to the differential equations, we will today do some questions based on the basics of variable separable. So in the previous class we have done some questions. Now we will take some more questions now. So the question we see here is we have to solve this differential equation. This wherein x is independent variable, y is dependent variable, and derivative is dy by dx. This is the first order derivative. So in this, let's try to solve it. So the very first thing we have to do in variable separable is we have to keep the variables x and with dx at one place, y with dy at another place, and then we have to integrate. Then we have to write the constant of integration, and that is our solution. That is basically the general solution of the given differential equation. So in this case, what we can do here, in this we can take x cube common. So if you take x cube common, it would be 1 minus y square dy by dx, and then if you take common in this, so y cube can be taken common, so it would be 1 plus x square is equal to 0. So next step would be, if you take LCM, what will happen? X cube times 1 minus y square dy plus y cube times 1 plus x square dx is equal to 0. Now let's do one thing. We keep dx part on the right hand side. So what we can do here? So x cube times 1 minus y square dy is equal to negative of y cube times 1 plus x square times dx. Now keep all x at one place, y at another place. So we can go for this 1 minus y square dy upon negative of y cube is equal to 1 plus x square times dx upon x cube. Okay, very good. Now we have to integrate. So we can integrate here. If you want, we can take minus negative common also. So then the next step would be integral of, if you take negative common, so we can write here y square upon y cube minus 1 upon y cube dy is equal to, it would be 1 upon x cube plus x square upon x cube dx. Okay. Now it's a simple integration. We will solve it. So here what we can do, y square upon y cube, this is 1 upon y dy minus, we can write y raised to the power negative 2 dy is equal to x raised to the power negative 3. Here it is 1 upon y cube, so y raised to the power minus 3, x raised to the power negative 3 plus dx, if you can separate also, plus 1 by x dx. Next step would be the integral of 1 by y is log y, so we can write ln y, and this will be y raised to the power minus 3 plus 1 upon minus 3 plus 1 is equal to, similarly x raised to the power negative 3 plus 1 upon negative 3 plus 1 plus ln x. And here we can write here c also. So if C is the constant of integration. We can write here C. So now what will happen? If you want, we can take log this side. Both the logs we can put it together. So in the next step, ln y minus ln x, and here it would be is equal to, we can write how much? X raised to the power minus 2 upon minus 2, and this will go that side. So it would be plus y raised to the power minus 2 upon, it would be minus 2. So in the next step, what should be done? Log ln y upon x is equal to, this would be how much? It would be minus 1 upon x square minus 1 upon y square plus c. So what we are observing here, that both are negative, so it's better we will keep it this side, so it will be better for us. So, or else our answer is this only, ln y upon x is equal to, negative is taken common, 1 by x square plus 1 by y square plus c. So this is the solution of the given differential equation. Now moving to the next question. We are dealing now with type 2 question. Type 2 means if the variables are mixed up in such a way that we are not able to separate them. Although we have the homogeneous method at the later stage that we shall be discussing next time. But here, with some minor changes, we can make the function integrable. We will be able to separate x and y. So we see here, what is this method is saying? It is saying dy by dx is f of ax plus by plus c, where b is not equal to 0. To solve this, substitute ax plus by plus c is equal to t. Then the equation reduces to separable type in the variable t and x, which can be solved. So for an example, x plus y, and here also x plus y. So if you put x plus y is equal to t, and then we will differentiate it, we will be able to substitute dy by dx, and we will get everything transformed in different forms. Y will vanish, and we will get in terms of v or t or whatever the values we are putting in here. So here, solution, let's see here. So here, let x plus y is equal to t. So differentiating both sides, what will happen? X differentiation is 1, y differentiation is dy by dx is equal to dt upon dx. Now what we require? We require here dy by dx. Here it is dy by dx. So therefore, implies that dy by dx is nothing but dt upon dx minus 1. So this result we are going to substitute in this place. In place of cos, within bracket x plus y, we can put t. Here also we can put t. So entire this differential equation will be transformed into, so now the given differential equation will be how much? Dt upon dx minus 1 is equal to cos t minus sin t. It's as simple as that. Implies that dt upon dx is equal to 1 plus cos t minus sin t. Okay. Now here only we can simplify this. So the next step would be dt upon 1 plus cos t minus sin t is equal to dx. Now we are going to integrate both sides. For this integration, we can actually go for the formula cos 2 theta and sin 2 theta. So let us see the next slide here. We know the formula cos 2 theta is equal to 1 minus tan square theta upon 1 plus tan square theta. In a similar way, sin 2 theta is equal to 2 tan theta upon 1 plus tan square theta. So here we have the integral of 1, that is basically dt upon 1 plus cos t minus sin t is equal to, and here if you are finding your dx, so integral of dx is it's x, so we can write here x plus c. Now as I mentioned here, we are going to transform this cos 2 theta and sin 2 theta in terms of tan. So it would be d theta upon 1 plus 1 minus tan square t upon 2 upon 1 plus tan square t by 2 minus 2 tan t by 2 upon 1 plus tan square t by 2 is equal to x plus c. Here if you take LCM, we know that 1 plus tan square t by 2 is secant square t by 2. So in the numerator it will be secant square t by 2 dt upon here 1 upon 1 LCM. So 1 plus tan square t by 2 plus 1 minus tan square t by 2, then this portion minus 2 tan t by 2 is equal to x plus c. Here we find tan square t by 2 and tan square t by 2 got cancelled, and now we are left with, implies that integral of secant square t by 2 dt upon 1 plus 1 is 2 and here 2, so we can take 2 common, so 2 is taken common, so it would be 1 minus tan t by 2 is equal to x plus c. Now this function has become the integrable function, so if we want to integrate, we can substitute the denominator. We can go for let 1 minus tan t by 2 is equal to y. So differentiating both sides with respect to y, what will happen here? So one differentiation is 0 only, so it would be minus of secant square t by 2 upon 2 dt is equal to dy. Now this substitution we are going to put in here. So we find that this portion can be substituted, moreover negative part is there, so no problem. We can go for negative of here it would be dy upon y. Why? Because we have assumed this portion as y is equal to x plus c. So here implies that negative ln y. Why it is ln y? Because log 1 by y is log y is equal to x plus c. Now return the value. So if you return the value here, so it would be negative of ln y is 1 minus tan t by 2 is equal to x plus c. Now again we have to return the value of t. So actually we see in the previous slide t is nothing but x plus y. So we can put the value here. So in place of t we can return it x plus y. So the final result is negative of ln 1 minus tan x plus y upon 2 is equal to x plus c. So this is the final result. This is the general solution of the given differential equation. So it is solved now. This is the general solution of the given differential equations. So we have solved this type 2 problem. Now we shall be moving to the next question. So here, now we will talk about the third type here. In third type, equation of the form wherein case 1 is this, and case 2 we have this. So what is case 1? dy by dx can be written as a1x plus b1y plus c1, and in the denominator we have a2x plus b2y plus c2. And here in the case 2, firstly we will solve this question. So again we see that if you take 3 common here, so in place of x plus y we can put here t. So let's see how to solve this. So x plus y times dx plus, now here 3 is taken common, so x plus y minus 4 dy is equal to 0. So here let x plus y is equal to t. So differentiate, if you differentiate both sides, what will happen? 1 plus dy by dx is equal to dt by dx, and we need here dy by dx. So first of all we will arrange this given differential equation in this form, implies that dy by dx can be written as, so x is this part, so it would be x plus y upon 3 within bracket x plus y minus 4, and here also we have the negative sign. So in the next step what we have to do is, we have to simply substitute the value of dy by dx. So dy by dx from here we can write it is dt upon dx minus 1. So this result we are putting here in place of dy by dx, and wherever x plus y is there we will put it here t. Here also we will put it t. So the result will be this one, dt upon dx minus 1. So dt upon dx minus 1 is equal to, negative is there, so we can go for 4 minus this. So we can write here t upon 4 minus 3t, 4 minus 3t. Okay. Now the next step would be dt by dx is equal to t upon 4 minus 3t plus 1. This side 1 will go. Now this result will be t plus 4 minus 3t upon 4 minus 3t. So dt by dx is equal to 3t plus t, so it is a 4t, 3t my negatives, and this is positive, so it would be a negative of 2t. So negative of 2t plus 4 upon 4 minus 3t. We can also write this way if you take 2 common. So we can write here 2 is taken common, so it will be 2 minus t, 2 minus t, and this would be here 2 minus t because I have taken minus common from both numerator and denominator, 2 minus t, and here 4 minus 3t, 4 minus 3t. So in the next step we will go for the next slide. So we have here dt upon dx is equal to 2. So we will go for cross multiplication. So it is minus 2 times 2 minus t. So it is 2 times 2 minus t upon 2 minus, it would be here 4 minus 3t. 4 minus 3t. We can go for this like 4 minus 3t dt upon 2 minus t is equal to 2 times dx. Now we have to make some arrangements here. Integration both sides here. So we have to integrate both sides. We can write here negative 3 plus 2 upon 2 minus t. So it would be how much? 3 2s are 6, and if you take minus here, then 3 2s are 6 and minus 3t minus 2. So 4 minus 3t upon 2t. We can write this perfectly fine. dt is equal to 2x plus c. 2 will be taken out, x. Why we have done this? Now this function is integrable function, because if you take LCM here, so in the denominator it would be 2 minus t here, and 3 2s are 6 minus 3t minus 2, so 4 minus 3t. So next step would be integral of 3 times dt minus 2 times 1 over 2 minus t dt and is equal to 2x plus c. So now if you take common here, minus, so it would be t minus 2. One more step we can take here, 3t plus 2 times ln t minus 2 is equal to 2x plus c. So this is the final solution, general solution of the given differential equation. We will just replace the value of t here. So we have assumed in the previous slide t is basically x plus y. So this substitution we have to return it. So in this case the final answer would be 3 times x plus y plus 2 times ln of x plus y minus 2 is equal to 2x plus c. This is nothing but the general solution of the given differential equation. This is the general solution of the given differential equation. So we were able to solve this type of questions. Now we will move to the next question here. So next question is this. We have to solve this, and we will end this session with this question. In the next session we will be talking about the homogeneous method, how we can differentiate the variables. So let me solve this question first. So we have here dy by dx is equal to x minus 2y plus 1, 2x plus y. So just go for the cross multiplication. So we can write dy times 2x plus 2y plus 3 is equal to dx times x minus 2y plus 1. If we open the bracket, so 2x dy plus 2y dy or plus 3 times dy is equal to x dx minus 2y dx plus dx. Now what we can do is we can put this 2x dy and 2y dy, 2y dx at one place. So we know that the differentiation of xy is x dy plus y dx. So this substitution is basic key point here. Otherwise, this is very easy question. So if we will proceed, we can do this way. 2y dy and plus 3 dy is equal to x dx minus, this will go right side, so it would be 2 times 2, and within bracket we can take bracket because it will be negative, then x dy, and this will be plus y dx plus dx. Now we have to integrate both sides, so we will integrate in a simple way. Everything will be integrated. So here we are finding y square, 2 times y square upon 2, so it would be 2 times y square upon 2 plus 3y is equal to x square upon 2 negative of 2. This is nothing but the derivative of xy. So here we can write here xy, and here dx. Basically we can write differentiation of xy. So that would be, so differentiation of xy, and then we have to write x. Now we need to arrange here, 2 and 2 get cancelled. So we are left here on the left hand side, y square plus 3y is equal to x square upon 2, and this x we can write this side, or here x minus 2xy and plus c. So this is basically the solution of the given differential equation. So this is the general solution of the given differential equation. So this was the last question of this differential equation, basic concepts. Now we shall be dealing in the next homogeneous, and we have linear and some other concepts in the next class. So thank you all of you. Thank you very much.